The mission of the National Radio Astronomy Observatory is to enable forefront research in the universe at radio wavelengths. We do that in a number of ways. First, by providing world-class telescopes, instrumentation, and expertise in radio astronomy. Second, by training scientists and engineers. And third, by promoting astronomy to foster a scientifically literate society. The NRAO was founded in 1956 in Green Bank, West Virginia, by our funding agency, the National Science Foundation, and our managing organization, Associated Universities.
The National Radio Astronomy Observatory has always been at the forefront of enabling science at radio wavelengths. They do this with a combination of scientists who enable the radio astronomy community to do their science, and engineers who create the instruments and the instrumentation for the next generation radio telescopes and enable the community to be far-reaching and thinking about science questions that can be addressed not just today, but tomorrow in the future.
The Very Large Array is a radio synthesis telescope comprised of 27 25-meter diameter antennas. The antennas are reconfigurable in a Y formation, and the frequency range spans the roughly 1 to 50 gigahertz. The VLA has enabled transformational science in a wide range of areas and continues to do so today.
To me, the near-term future of the VLA is in time domain astronomy. That could be in detecting radio transient events themselves or the radio counterparts to events discovered at other wavelengths. Unlike any other radio telescope on the planet, the VLA has the combination of sensitivity and spatial resolution to contribute to this golden age of multi-messenger astronomy.
What excites me most about the data that comes from the Very Large Array is the fact that every time we point the telescope at some celestial object, within those observations is new information, things that we didn't know about before, and there's always the potential for cutting-edge discovery.
The idea for a next-generation VLA was inspired by the VLA itself and the Atacama Large Millimeter Array in northern Chile. The NRAO, in conjunction with our science community, envisioned the ngVLA as a new large radio interferometer that will open up new discovery space in astronomy. Our idea for this is an instrument that is 10 times the sensitivity and 10 times the spatial resolution of the VLA or ALMA.
I am very excited about the data that will come from a next generation VLA. It will be exquisite in detail, the sensitivity will be unparalleled, and the opportunities that it will open up in many different science areas is really one of the things that excites me most. That this is a very, it's an open facility that anyone who has a great science idea can propose for and use, and its flexibility and its versatility enable many more science questions to be addressed than what we can think of right now.
The next generation VLA has been designed to accomplish 5 main science goals. These main science goals include unveiling solar system analogs, probing the initial conditions for life through astrochemistry, charting the assembly, structure, and evolution of galaxies over cosmic time, perform fundamental tests of gravity, and understand the evolution of black holes.
One of the things I work on is measuring the distance to stars and star-forming regions, and measuring their distance and how they move within the star-forming regions. Currently, we can only do 20, maybe up to 100 stars in these star-forming regions. Star-forming regions contain thousands, tens of thousands, hundreds of thousands of stars. With the next generation VLA, we'll be able to study 10,000 stars in these star-forming regions, which will help us give definitive answers to major questions in star formation.
The ngVLA will be a superb black hole hunting machine, the ultimate black hole hunting machine. The ngVLA's high-resolution imaging, combined with its fast mapping capabilities, will enable it to search for radio transients associated with gravitational wave sources, neutrino transients, and optical observatory transients, and identify those with black holes that are involved in violent merger events.